Hey everyone, we're working with logical arguments again. We're actually getting into the two-column proofs today. So we're proving segment relationships as we do it, but it's going to be mostly working with two-column proofs. So we have a couple new postulates to talk about. We got a rule postulate and the segment addition postulate. The ruler postulate basically is just saying if you take a ruler or take any point or segment and we can match up that segment on a number line. So think of it if we were measuring a line segment, would put the zero part of the ruler on one end. We'd look at the other end of the line segment, match up wherever our number is, and that's how we get our measurement. That's what that ruler postulate works with. And then the segment addition postulate is one we'd worked with before, the segment addition rules. So we have points A, B, and C are collinear. If they're collinear, then B is between A and C if and only if AB plus BC equals AC. So remember, we worked with that, trying to figure that out. So if AB plus BC doesn't equal AC, then B is not going to be between those 2 points because we have a measurement that's longer than or shorter than what our line segment would look like. So hopefully that makes sense. We're going to be using that as we kind of go forward today with what we're working on. So we're going to get right into the two-column proofs. It's all we're going to work on today. We'll see this one first, and then we'll kind of work through it, fill some one in, and then we'll do one long one. And then we'll answer a couple questions, and then that'll be it for today. We'll have homework tonight, kind of working with the two-column proofs. It's going to be you working on those on your own to try to prove your stuff out. So when we're looking at two-column proof, just like the flow proofs, you're always going to be given something, and you're always going to have to prove something. And with our two-column proofs, more often than not, you're going to have a picture. So we have our picture. We're given that Q is the midpoint of PR. We're given that R is the midpoint of QS. And then we're asked to prove that PR equals QS. So what I'm going to do is I'm going to kind of draw in some stuff here in colors, and then we'll work through marking the drawing up, which you should always do when you're doing a proof to kind of help you go through what we're trying to do. So we're looking at two different line segments to start. We're looking at PR, and then I change color so it's all kind of color coordinated. And then we're looking at QS. So we're told that in both instances, go back to my red, we're told that Q is the midpoint of PR. So because we know that's the midpoint, we know right away that those 2 points are congruent. We also know R is the midpoint of QS, so I'm going to use 2 blue slash marks. We know those 2 sides are congruent. And now what we're trying to prove, I'm going to kind of write out in purple, is we're trying to prove that PR, so this bar, that line segment, is congruent to that line segment. So that's what we're trying to prove. We have our lines kind of marked up. I'm going to switch back to red here. And we're going to start going through our proof and take a look at it. I'm going to bring it up and show you it, and then we'll walk through it step by step to kind of figure out how everything works. So here's what a two-column proof looks like. The statement side is basically from our flow chart. Those are the statements that go in the boxes we were working with in the flow chart. Our reason column is the reasons that we put under the box. We're just kind of getting right with the arrows. We've listed the steps 1 to 8 to try to get to our proof. So this proof's going to take us 8 steps. What I mentioned yesterday in the flow proof, and then also with this one, is your first reason, your first statement is always going to be either all of your givens or one of your givens. So in this instance, we're going to start with just one of the givens. So our given statement, Q is the midpoint of PR. Our reason is given. That's what it was. We were told that, so we don't have to do anything about that. Our next statement then, from what we know about midpoints and what we've kind of drawn on the graph and looked at, is we know then that PQ is equal to QR. Again, that is the definition of a midpoint. The midpoint of a line segment divides the line segment into 2 equal halves. Those 2 segments are PQ, QR. Definition of midpoint, we know they're equal. Then we're going to bring in our other given statement. R is the midpoint of QS. Again, that was another given. Good to go. Same thing. Same step kind of our proof. QR is equal to RS, definition of a midpoint. Just like the first segment, we know that's true. So now we're in the stuff that we got to kind of, now how are we going to get to the end? So what we can do from here is we can kind of look, if we look at our drawing and we see we've kind of slipped up the hash marks that this middle segment here, which I'm going to kind of do as like a half arc in red, is part of both line segments, and it's the same size in both of them. So from that, we can say then that PQ is equal to RF. That's the transitive property. Kind of think of it as A equal to B and B is equal to C, then A is equal to C. That's what that's doing there. From there now, we have PQ equals RS. Kind of think back to our algebra. We're adding QR to both sides here. So when we add the same thing to both sides of an equal sign, it keeps the same values of the equal, kind of. That's the addition property of algebra. It's also the addition property for what we're doing here. Then we look at, from the postulate we just learned, PQ plus QR equals PR. That's our segment addition postulate. QR plus RS equals QS, again, as part of the segment addition postulate. So now we know we got true statements there because that's what we know to do. So from there, then, we can kind of substitute and really get rid of the PQ plus QR and the QR plus RS, and you're left with what you were trying to prove. PR equals QS, and your reason there is substitution. And we've kind of done our first two-column proof, proving from a line segment thing why something's true. Hope that makes sense. I hope it's kind of clear. These are what these are all going to be. Unfortunately for you guys, you're not going to have them all given to you and done this way. We're going to have to kind of fill in and start from scratch. What are we trying to prove? So let's go look at our second examples. So we're going to look at the one on the left first. So we have our picture. We're given BC equals DE. We're trying to prove that AB plus DE is going to equal AC. So our given, that is congruent to that. So we start off BC equals DC, that's your given. They've told you that, so that's our given reason. Our next thing, we see the reason we're looking at is the segment addition postulate. So now we got to kind of figure out what are they going with the segment addition postulate. Well, from there, what I think they're doing is, if we look and call it in, is AB plus BC. So they're doing this. If this plus that equals, we can add those together. And that's what they did. AB plus BC equals AC. That's our segment addition postulate. That's what we know to be true, that the distance from A to B plus the distance from B to C is going to be the distance of the whole thing. And then they go to what they tried to prove, where we're pretty much substituting out B, C, and DE because they're equal. And we have our substitution property for our proof. So we're able to prove that, given that, we're able to prove that AB plus DE equaled AC. Does that make sense? Okay, glad that made sense. This one's a little longer. Again, we're given the two-column proof, some missing stuff. We're going to try to figure out what's happening. And we're going to start looking at what we were given, what our given statements are, what can we kind of mark up the graph with to see if we can kind of piece some things together, and then we're going to go from there. So, pretty similar to the last one. I'm going to kind of color code it a little bit. I'm going to make, we're going to do blue, and we have PQ and QR as one line segment we're kind of looking at, or we're given information about. And then we're also told, we'll do purple, that QS is some other line segment we're given information about with Q, where Q is between P and R is between Q and S. So then what we're told, which I'm going to kind of slash mark out in red, is that PR is equal to RS. And now what we're trying to prove is, I will do in green, we're trying to prove that these 2 points, the green slash marks, are equal. So we start off with our given statement. Q is between P and R, that's a given. So then we go to the next thing, we have PQ plus QR equals PR. So again, that's our segment addition postulate. That's what we're doing. PQ plus QR is going to equal RS. Now we're told R is between Q and S. Again, that's another given. So then we have another segment addition postulate. So they're obviously looking for QR plus RS equals QS. Then we have our third given. We're told again that PR equals QS, which is an important piece of information to help us get to the rest of our proof. So because PR equals RS, we can kind of go back to our segment addition postulates and substitute in PQ plus QR is going to equal QR plus RS. Does that make sense? Okay. So then we look and we say, okay, now how are we going to get to our end? And now we can look and we say both sides have a QR. So we're going to subtract out QR. So the PQ plus QR minus QR is going to equal QR plus RS minus QR. So remember, if we were doing an algebra proof like this, I'm going to kind of draw it in. These cancel, and now these cancel, and you're left with PQ equals RS, which is what we wanted to do. So we'll just kind of substitute that out, and that's our reason. Does that make sense? These all flow pretty logically. You just got to kind of look and see how they are. I know in the beginning, they're definitely going to be confusing. Trust me. I understand that. You're going to have to kind of think it through. I know you were all able to do it. We're all pretty good with math here, and we can kind of see the stuff out. So I'm pretty confident we're all going to be able to do it. Well, it's just practice. I mean, this is proof after proof after proof. The more proofs you do, the better practice you're going to get to be able to handle what we're looking at. Now, here's one that we're going to kind of work through ourselves. It looks very similar to the last one. We're asked to prove, given that PR is congruent to QS, we want to prove that PQ is congruent to RS. So again, I'm going to color code our drawing out. Blue for PR. Like a PR is blue. We'll do RS in purple again, or QS in purple. So we have our kind of markers off. We're told that I'll do in red that PR is congruent to RS. So then we're going to kind of look and see what we're trying to prove. We're trying to prove that PQ is congruent to RS. Again, I suggest drawing a picture, kind of mark it up in colors if you need to, just to kind of think it through. So, statement one. We're given PR is congruent to QS. I would definitely recommend numbering both sides of your proof as well. So that's our given. Pretty simple to see. So from there, what we can say is that 2 PR equals, whoops, I'm going to put my bars on, I forgot my bars, QS. We're able to say that because that's the definition of congruent. Congruent sides have the same measurement. So we're just going to abbreviate def of congruence. Does everybody see that? Everybody kind of understands how we're able to do that? Okay. So now what we're going to be able to say, we kind of look and say, what am I trying to do? How am I going to try to get the PQ to RS? We know we got some theorems and some things we can do. So I'm going to do 3. I'm going to go and say PQ plus QR equals PR. And on the same line, because it's kind of the same thing, I can say QR plus RS equals QS. So it's kind of small, I want to squeeze that in. But everybody sees we can do that, right? Segment addition postulate, PQ plus QR equals PR. QR plus RS equals QS. So that's my reason here. Seg addition postulate. You can abbreviate. You'll start seeing some other abbreviations we can use as we get into this. Okay. So now we know that. Step 4. What I can look at and see now is I can kind of get rid of PR and QS. So I'm left with PQ plus QR equals QR plus RS. And this is substitution. So we substituted PQ for RS, or all that, the segment addition parts for the things. Okay, now, again, another long line, I'm going to kind of step back a little bit. We're going to do PQ plus QR minus QR equals QR plus RS minus QR. And that's our subtraction property. If you are abbreviating, try not to abbreviate substitution and subtraction both as SUB. That'll confuse me as I'm grading stuff. So now when we do that, our QRs are all going to cancel. We're left with, on line 6, PQ equals RS. Again, this is substitution. Does everybody understand how we're able to do that, hopefully? Okay. And then we're left with, from what we have, because our sides have the same measure, we can then say segment PQ is congruent, segment RS, definition of congruence. So as you can see, don't be worried about using the same reason code more than once. We use definition of congruence twice. We use segment addition once there. We use substitution twice. Excuse me. So don't worry about using them more than once. You're probably going to have to as we're going through the proofs. It's just if you can do it on the same line like we did on line 3, we kind of used our segment addition parcel twice on the same line. So we had 2 different statements. That's perfectly fine. If you want to do these 2 different statements on separate lines, again, that's fine as well. Just sometimes it's easier to flow with what that next step's going to be to make it work. Excuse me. Does that make sense? Hope everybody understood that. That's really working through the first proof that we have. Okay, so now the next one we're going to talk about are segment congruences. Sorry. So remember, segment measures, they're reflexive, symmetric, and transitive, so they can kind of all flip-flop around. It's the same thing with the congruences. So we have theorem 2.1. This is our second theorem. We had a theorem yesterday, which was the midpoint theorem, where the midpoint divides a segment into 2 equal halves. So now we're working with theorem 2.2, where it's the properties of segment congruence. We have the reflexive property. Segment AB is congruent to segment AB. I know it looks weird to have to say that and have a property for it, but it is something that we are going to need when we start doing proofs later on in further sections. Our symmetric property, again, if AB is congruent to CD, then CD is congruent to AB. We can flip them around and move order of that. And then our transitive proof, the kind of thing that ties with if A equals B and B equals C, then A equals C is if AB is congruent to CD and CD is congruent to EF, then segment AB is going to be congruent to segment EF. Again, it's a big thing we need to work with and proofs down the road. So we're kind of slowly building up our bank of knowledge that we're going to need to do proofs later on. Again, what I'm going to try to do is come up with some sort of idea or a tip or something, and even you might come up with it on your own, is have like a piece of paper or a file somewhere where you're kind of typing in all these theorems and postulates that we're learning as we go. And then we will use them as you need them, so you can kind of pull that sheet out as you're doing proofs as we're going through other work. So now, based on these, we're going to answer 3 quick questions, and then that is going to be the end of our lesson today. Hope you did well on the quiz, and I hope you do well on the homework. There is homework tonight. It's 7 problems, doing proofs, kind of working through them. So when we look at our statements, we're going to justify each statement, take a few minutes and kind of figure out what property of congruence we're looking at, enter them into Edpuzzle, and then we'll come back and look at the answers. Okay, so we have our answers. We got to go through it and figure out what it is. So we're told if DE equals GH, then GH equals DE. Oh, look, they just flipped the numbers around. So that is our symmetric property. Sorry, lost my head there for a minute. And I just spelled symmetric wrong. It's Friday. Sorry. Still doesn't look right to me. It is though. The symmetric property of congruence. Okay, second one. If A is congruent to RS, segment AB is congruent to segment RS. If segment RS is congruent to segment WY, then segment AB is congruent to segment WY. This is our transitive property. Try to get in the habit of reading the segments too. So like if you see the bar, then it's segment AB is congruent to segment RS. If you just see AB, then it's AB is equal to RS. So kind of remember we're talking about segments or measures. Kind of think that way as we do it. And then the last one, obviously, because there are only 3 of them, this has to be our reflexive. And I am not going to write out of congruence this time. So kind of remember those. We'll need these, and like I said, we're going to need these as we're doing proofs. We can use them as reasons now because they've been proven. You know that they've been proven because they're a theorem. We haven't proven them ourselves. There will be some theorems before I introduce them that we're actually going to prove them out so that we can see what it is so you understand why. So hope everybody understood this today. Hope it was clear. Like I say, work on the homework. If you have any questions, we'll kind of go over all of these on Monday. I'm going to start off our lesson on Monday with going over all the homework problems. I think I'm probably going to do all of them, whether it's going over all of them or just flashing the answers up there to answer questions if you have any. And then Monday is basically just going to be plugging through a bunch more proofs to kind of give us practice on doing it before we move on to the angle proofs. Because like I say, the more you do proofs, the better you get at them, the easier they're going to be to see and understand. So I hope everybody has a good weekend, and I will see all of you guys in class on Monday.